Okay, on this particular problem, you need to find the number that makes the expression a perfect square trinomial, and then you're going to factor it into a binomial, okay? So here, you're going to take half of 12, you're going to square it, so it's negative 6 squared, which is 36, so that's what goes right here. This factors into x minus 6, and so we need it as a binomial square, so you just simply write it as x minus 6 squared. And that's my answer, and 36 is my answer. Here, you're going to take half of 9 and square it, so that's 81 over 4. So that goes 81 over 4. That means this is x plus 9 over 2 squared. I want you to notice that this goes right here. The negative 6 went right here. And that's how you determine, or that's how you make a square binomial, okay? Now, the next one, Aaron and her father launched a rocket from ground. Okay, this is the equation you're going to put in your calculator. Negative 16t squared plus 80. Now, notice what you got to look. How long is the rocket in the air? So that is a root. How high? That's your vertex. All right, what is the maximum height? And when does this occur? Oh, I'm sorry. No, this is your vertex. I apologize. I didn't read the question. This one is how high is the rocket after 4 seconds. So that means when x is equal to 4, what is y? Okay? And then finally, when is the rocket 96? Well, when y is 96, what is x? Okay, so those are the questions that we're going to answer. So let's go to our calculator. Here's the equation. I'm going to graph it. Now, notice it only shows this. So I need just the first quadrant. So I'm going to go to my window. Since it's the first quadrant, I need this to be -1. Now, it's a rocket, so I already saw where it lands. So let's just make that a 10, and we're going to count by ones. Now, since it's a rocket, think about it. I'm going to take this at -1, but the height of a rocket could be anywhere like 100, 120. Let's play it safe. Let's go 150 feet in the air. That seems like a good distance. And if we're counting between -1 and 150, I want my scale to be, let's say about 20. Okay, so let's execute. All right. That seems to be a pretty good graph. And if you don't like that graph, just arrow up a little bit, and that makes it a better picture. Now, remember, the things we're trying to find is how long is the rocket in the air. So when I go to GSolve, I find my roots. Well, this one is where it's at 0. The height is 0. But if I arrow over, it's in the air 5 seconds, so a total of 5 seconds. So when I go over here, the answer is 5 seconds. Now, the next thing I want to look at is when x is 4, what is y? So I'm going to go back to the calculator. I hit Shift F1, which is my trace function. I want to see when x is 4. All right? Hit Enter. So when x is 4, my height is going to be 64 feet. All right? So 64 feet is my answer. The next thing I want to tackle is the maximum height. So I want the vertex. All right? Remember, your vertex is going to be seconds, and then, of course, height. So let's go back to the calculator, and I'm going to find the vertex. So GSolve, I want the maximum. And at 2.5 seconds, the height is going to be 100. All right, so at 2.5 seconds, the height is going to be 100 feet, and put it as a coordinate point, okay? And then finally, when is the rocket 96 feet? So notice that's an equation, y equals 96. So if you go to the calculator and put in y equals 96, so exit, I'm going to put 96 here, and I'm just going to graph it. Now notice it crosses at 2 points on the graph. It crosses at 2 points on the graph. So I'm going to find the intersecting point. GSolve, intersection. The first one is at 2 seconds, it's going to be at 96 feet. And of course, at 3 seconds, it's going to be at 96 feet. So I'm going to put 2 seconds, and x equals 3 seconds. The rocket will be at 96 feet. Now, I could write a complete sentence, but just to shorten purposes, I'm just going to leave it as is. Now, this one, Miss Zagara needs to make a dog run for her grandpuppy who has come to town for the holidays. All right, she's only got 48 feet of fencing. All right, 48 feet in defenses. That means if you build a rectangular yard, you're only going to have a perimeter of 48. Well, think about this. If I walk only from here to here, I've only used up 24 feet. So if this is x, and I have to walk 24 feet, well, then this side has to be 24 minus x, because it's 24 minus whatever you have already walked. Now, we want to find the area. So we use the perimeter to find these two variables. Now we're going to use the area to find the area of the rectangle. Remember, area is length times width. So area is going to be x times 24 minus x. And you can either put it in the calculator like that, or you can make it x squared. I'm sorry. Let's distribute that x. So I'm going to get area is equal to 24x minus x squared. And I'm going to put this in the calculator like that. So that's the formula that we're going to use. So again, go to your calculator. We're going to clear these two out. All right. So I get 24x minus x squared. And I'm going to graph it. Now look how big that got. So I noticed that it's going to go pretty far to the right. So I'm going to go to my window. Since my max, I'm going to go 50. That seems like a good max. And since I'm going from 0 to 50, I'm going to count by tens. Let's see how that looks so far. Not so bad. So we noticed that the max is going to be around 25. All right, let's go to my window again. Let's go to Y max. It's already up to 120. Let's try 200. And we're going to count by 20. So let's see what that looks like. That's a good scale. In fact, I can use my keypad to make it even better. All right, now, when we're talking about this question, when we want to find the maximum area is basically defined right here at our maximum. So we want to find our maximum. So we're G-solve. We're going for maximum. And we're going to have a maximum area of 144 when the x value is 12. So notice, okay, at an area of 144, you're going to have a max, or a length of 12, you'll have a maximum area of 144. So by solving that, when x is equal to 12, you'll have an area of 144 square feet. All right, and that's what we were looking for. Let's see how much time we've used so far. We've gone 7 minutes, so we've got a few more minutes to complete 8 problems. All right, so number 14. We're going to complete the square and state the vertex, all right? Let's go ahead and put this equal to 0. Move the 10 over. X squared plus 8x equals 10. Now here, again, we're going to take half of b. So half of b, which is 4, square it, and that's 16. Okay, half of b, square it. That's going to be 4 squared, which is 16. So we're going to add 16 to this side. So I end up getting x plus 4 squared equals 26. I'm going to subtract the 26 on both sides. And I get x plus 4 squared minus 26 equals 0. And my vertex is at negative 4, negative 26. And that's all you got to do to put it in vertex form. Number 15. Again, 3x squared minus 12x minus 4 equals 0. Now, for those of you who are waiting to see when it has a leading coefficient other than 1, I have a 3 there. First, I'm going to move the 4 over, and I get 3x squared minus 12x equals 4. Now, recall that 3 problems previously, I factored out a 2 out of all 3. Notice all of these are not factorable by 3. 12 is, but 4 is not, so I can't do it. So I'm going to factor out a 3 out of this portion. Factor out a 3, and I'm left with x squared minus 4x. All right? Now, I'm going to take half of b and square it. So negative 4 divided by 2 and square it. So that's going to be negative 2 squared, which is 4. So plus 4 plus 4. This then becomes x minus 2 squared, because that's the perfect binomial, equals 8. Now, can you pick out the problem, or pick out the error? Well, if you said that I added the 4 without multiplying, you are correct. You have to multiply that 3 times that 4 there and get 12. So you saw the mistake I just made. Make sure you don't make the same mistake. Now, 12 plus 4 is 16. We're going to move that 16 over, and I get 3 times x minus 2 squared minus 16 equals 0. And my vertex is going to be 2, negative 16. And that's how you do vertex form. All right, we're at 10 minutes, maybe just a few more. All right, the next couple ones are pretty simple. If you look at this, state the vertex, and if it's a max or min. Well, notice A is positive. That means it's going to look like this. Therefore, that's going to be a minimum. My vertex is going to be at 5, negative 14. And it's a minimum, like I said. That's a negative, therefore it's going to go like this. It's opening downward, so that's going to be a max. My vertex is at negative 2, positive 4. Okay? Finally, the last three, you're just simply multiplying. This is 3 times square root of 2 times 2 times square root of 3. 3 times 2 is 6. Square root of 2 times square root of 3 is square root of 6. And there's your answer. 3 square root of 21 is the square root of 7 times the square root of 3. Square root of 6 is the square root of 3 times the square root of 2. Notice when you multiply a square root times itself, that equals 3. So bring down your 3. Square root of 7 times square root of 2. That's 9. Square root of 7 times square root of 2 is the square root of 14. And there's your answer. The last one, square root of 32. That's 4 square root of 16 times square root of 2, 3, and square root of 2. Now notice, square root of 16 is 4, so this is 4 times 4. Square root of 2 times square root of 2 is just 2. And of course, bring down your times 3. And when you multiply all that together, 4 times 4 is 16, times 2 is 32 times 3, which is 96. And that completes our recording.